We're looking at rational expressions and equations in Chapter 4. This is Unit 2, Chapter 4, Section 4.2. Demonstrate equivalent forms of rational expressions. In this lesson, we will look at simplifying rational expressions. We will identify the non-permissible values, or NPVs, and we'll write equivalent forms of a rational expression. Let's recall factoring binomials. There are two types of binomials that you will need to know how to factor in this unit. We always first look for the greatest common factor. Sometimes when we take the greatest common factor outside, we may be left with the difference of two perfect squares. You need to be able to identify the difference between these two types of binomials. A rational expression is any expression that can be written as the quotient of two polynomials. So we have p of x over q of x, where q of x cannot equal 0. We cannot have the denominator 0, as that would make the expression undefined. A non-permissible value, if there's a variable in the rational expression in the denominator, we cannot have the denominator equal to 0. So if we look at 4 over x, x cannot equal 0, as that would give us 4 over 0, which is undefined. If we look at the rational expression 1 over x plus 2, where x cannot equal negative 2, we would see that 1 over negative 2 plus 2 would give us 1 over 0. Once again, undefined. Therefore, our non-permissible value will be x cannot equal negative 2. Simplifying rational expressions. To simplify rational expressions, we must cancel common factors that are in the numerator and the denominator. So as you can see here, we have a common factor of x plus 1 in the numerator and denominator. To simplify, we can simply cancel these out, and we can be left with a simplified expression would be 3 over 2x. Yet there are NPVs. According to the solution, x cannot equal 0. Yet in the denominator, in the step before it, x cannot equal 0, and x cannot equal negative 1. We should not forget this. This is a part of our NPVs. So the NPVs, x cannot equal 0, and x cannot equal negative 1. The NPVs includes anything that has ever been in the denominator during the process of simplifying. We should always factor before simplifying. If the polynomial in the numerator or in the denominator is not factored, we must factor before simplifying. X plus 4 is unfactorable. It's simplified as much as possible, yet x squared subtract 16 is a difference of two perfect squares. So we can factor that to be x plus 4, x subtract 4. We see there are a common factor of x plus 4, and so we can cancel. That would leave us with 1 over x subtract 4. The NPVs, of course, even though the solution, the simplified answer, only shows us that x cannot equal 4, we see that in the step above it, x cannot equal 4 right here, but yet this one also shows that x cannot equal negative 4. Since if x equaled negative 4, then that would give us 0. 0 times this factor would give us 0 in the denominator and make our expression undefined. So NPVs, x cannot equal negative 4, and x cannot equal 4. Let's have a look at another example. We see that when you factor the binomial in the numerator, x is a common factor. When we take it outside, inside we have 2x plus 1. In the denominator, 5 is a common factor. We take it outside, and we're left with inside the bracket 2x plus 1. These are common factors that we can cancel, and our simplified expression is x over 5. Yet, although the simplified expression does not show any NPVs, in this step we have 2x plus 1 cannot equal 0. So 2x cannot equal 1. X cannot equal 1/2. 1/2 is our NPV. Opposite factors. When we cancel, normally we get 1 when we cancel a common factor on top and bottom. In this case, we have opposite factors. So when we cancel these two, we would get negative 1. Since if we had x subtract 2 over, and we took a factor of negative 1 outside, that would give us negative 2 plus x. We could rewrite this as x subtract 2 over negative 1 outside of x subtract 2, canceling this common factor and giving us negative 1. So if you look at here, you have a positive 2 and a negative 2, and a negative x and a positive x. So that will constitute negative or opposite factors and giving us a negative 1 when we cancel. Let's look at another example. If we look here, once we factor, we find a common factor of 4, leaving the other factor to be x plus 3. In the denominator, there's a common factor of 6, leaving the other factor 3 subtract x. We are unable to cancel this as opposite factors, yet we can simplify the 4 over 6, since 4 over 6 simplifies to be 2 over 3. We have 2 over 3 x plus 3, 3 subtract x. Our NPV, of course, will be x cannot equal 3. Since if x was equal 3 here, that would give us 0 times 6, which would give us 0 in the denominator, and it's undefined. Rational expressions are not equivalent if the non-permissible values are different. This is very important. If we simplify two expressions, their NPVs must be the same in order for them to be equivalent. Let's have a look. So right here in the first expression, x cannot equal 4. So once we simplify the second expression, we would get 4 outside of x plus 3 over 4 outside of x subtract 4. The common factor of 4 can cancel, of course, and the NPV will be x cannot equal 4. So we have a simplified expression that is equal to the first expression, and the NPVs are also the same. So yes, these expressions are equivalent. In the second example, the first expression, the x cannot equal 5 is the NPV. So once we simplify the second expression, we would have 5 outside of x plus 5 over, it's a difference of two perfect squares in the denominator, x plus 5, x subtract 5. We can cancel the common factor of x plus 5, we would leave us with 5 over x subtract 5. The NPVs, of course, will pertain to this step. X cannot be negative 5, and x cannot be 5. So this solution, this simplified expression, there are 2 NPVs, and in the first expression there was only 1. So no, these expressions are not equivalent since the NPVs are different. If we look at the last expressions, the first expression has an NPV of x cannot equal 3. Once we simplify the second expression, we would have 3x plus 2 over 2 x subtract 3. The NPV would be x cannot equal 3. So the NPVs are the same. The NPVs for both expressions are the same. Yet the simplified expression is not. Therefore, they are not equivalent. Sometimes people make common errors when simplifying. One popular error is that we try to cancel the terms. So you would cancel x over x, leaving you with 2 over 4, which is 1/2. This is incorrect since x's are terms, not factors. You could only cancel factors. Common factors. Factors are things that are multiplied by each other. Another common mistake is not including all NPVs. So we have a tendency to simplify the expression and have x plus 5 over 3, and then say that there are no NPVs, on which there are, even though the simplified expression doesn't show any NPVs. We look at this step, which shows us that NPV x cannot equal 2. So we must include all NPVs that were throughout the solution in simplifying. In summary, when examining a rational expression, be aware that it may have non-permissible values if there's a variable in the denominator. The denominator of a rational expression cannot be 0, as that will give us an undefined expression. We cannot divide by 0. Remember to cancel factors and not terms. And always keep NPVs in mind, as they will continue throughout this unit.